This is a good example, and I took this example from the book called The Code Book. And here in this example, this is our encrypted message. And we are going to use the patterns of human language and the one-to-one links, and we are going to crack this secret key. Is a single alphabet shift key. We're going to crack this. This is the key that was used to create the encrypted message. First, we'll do a quick scan of the encrypted message against the known letter frequency and the frequency of letter combinations and short words and so on. And I'm going to fast forward a bit through this step, but with just a very small trial and error, just a tad bit of time and effort, there are 7 letters that right away we could be pretty confident with, which even gives us some full words that we now have decrypted or cracked. And I know the green here is hard to see, but the point here is just look at how much green there is. And this is due to the much higher frequency of the certain letters and letter combinations and the short words. So next, one by one, we use context clues and make safe guesses to start filling in some gaps. So this is probably a G. Now that we have the G, we know that this is probably an S, and so on. And the more you unlock, the more context you now have to unlock the remaining encrypted letters. So with the frequency analysis we just did and a few context clues, we now have quite a bit. We've cracked more than half of this secret shift. And the shift phrases themselves might have their own patterns and their own context clues. So in this example, this is a known phrase from a book. Now, also 2 more context clues that we can draw on. And that's it. We have found the secret key. And to do this, this took us about 15 steps. And if you were to do this as an actual exercise, it would take you in the realm of minutes. It would not take you very long to sit down and do what we just did. And you know, we cycled through common language patterns. We did a series of guesses and checks along each link between input and output of our of the encrypted message that we had. So what we just demonstrated, we demonstrated that the Paired-Pattern-Pitfall is an enormous problem. Now, granted, we only had this one alphabet secret shift, but because of this, it only took us about 15 steps versus the theoretical trillions and trillions of number of steps that it should have taken us in theory. So the Enigma, while it had vast encryption capabilities, at its foundation is the same problem. And this new electric computer could do the same thing we just did and easily overcome this enormity of numbers. And that is why modern cryptography is built and designed specifically to solve these 2 patterns, to remove patterns and remove the one-to-one pairing.